2011 Senior 2011 Physics Senior External Exam, Paper 1, Part B, Short Response, Question 3. Respond to Question 3 on page 2 of your response book, which I shall have at the bottom of the page. Reading the question. A trolley is released from rest. So its initial velocity is 0, down a frictionless incline, so you don't need to consider friction, and then onto a frictionless horizontal plane. So in this particular place here, we take this as our 0 in height. Our gravitational potential energy will be 0. From whatever height it's released from, its gravitational potential energy will be maximum. The trolley had the following values of potential energy relative to the horizontal plane as it moved down the incline. It took 3 seconds to reach the horizontal plane. Starting here at 0 with a potential energy of 9. After 1 second, it's lost 1 joule of potential energy, you have a total of 8. After 2 seconds, it's lost a total of 4 joule of potential energy to have 9. And then after 3 seconds, it's lost all of its potential energy. And so here, its potential energy will be 0. Its kinetic energy will be maximum. Here when it started, its potential energy will be maximum, and because it's released from rest, its kinetic energy will be 0. Draw a graph of potential energy versus time from the data given. I've taken the liberty of going to the response book and drawing the graph, and so I have the graph here. I'll just focus it for you. Okay, you will notice here on the vertical axis I have potential energy. Potential energy goes up to 9, so therefore I've taken 2 centimeters to be 1, and so therefore the 19 centimeter grid can take me up to 9 for my potential energy, and the unit there is joule. On my horizontal axis I've got time. We need to get to a maximum of 3 seconds, so the best way to do that is for each 5 centimeters to be 1 second, and so that's to fit the maximum there across the grid. Now I've plotted my points: 0, 9, 1 second and 8 joule, 2 seconds and 5 joule, 3 seconds and 0 joule. So we see a parabolic arc here. With my pencil I need to draw a line of best fit, but the best way to draw a line of less fit is using the curve of your wrist. So therefore I need to turn my page around so that I can start here and use the curve of my wrist to go through and intersect the line through as many points as possible. I run backwards and forwards a few times so that I can get the angle right. Let me just put it there so it's easier there for you to see. So again, sorry, I didn't have that in the right position to start off with. I can practice running over. You notice my pencil here has an eraser on the end, so that if I don't get it right first time, because I'm drawing with pencil, I can rub it out. So there we go. There's our curve. Go over it a little bit heavier. There we are, and we have our curve drawn. Alright, now let's go to the questions. So that was question A. Draw a graph of potential energy versus time from the data given. From the graph you have drawn, determine the potential energy 1.5 seconds from the start. So here's my graph. So I've got to go to 1.5 seconds. And at 1.5 seconds I read up. And I follow through here to where that line intersects my graph. And then from where that line intersects my graph, I go over. And you can see there, at 1.5 seconds, that's 6.7 joule. So 1.5 seconds from my graph, my gravitational potential energy is 6.7 joule. 4 seconds from the start, 4 seconds from the start, that's off my graph. My gravitational potential energy here is when it has reached the horizontal plane at 0. So it's on the horizontal plane. So the gravitational potential energy there will be 0.